the last one that's due. Oh, you also have some due on the 22nd. Higher order derivatives and concavity. That's pretty long. I accept that okay. Okay, that's pretty long, that's due. This one, analyzing graphs, is due the next day, so that's also due. That's fairly long, it's also. And one more. Maximum and minima. That's short. Okay, so you have some considerable amount of homework that's due. So let's talk about how to do these homework problems. So let's go to this one first. This was the longest one. Homework, higher order derivatives. ACC means acceleration and concavity. So this is the longest homework that's due. Now let's look at this one. Calculate the second derivative for this function. So what's the answer to this? The second derivative. So the first derivative is what? Minus 8x, right? First derivative, I'm sorry, minus 8x plus 1. Right? This one is minus 8x plus 1. So the derivative of that is what? Minus 8. Let's just do that on the board quickly. So it says y equals minus 4x squared plus x. And it says first dy dx is what? Minus 8x plus 1. And then the derivative of that means, we write it like that. That's the notation for the second derivative, is what? The derivative of this is minus 8. Okay? Okay. About the next one. So that's the same idea, right? I don't think we have to do that one. Okay, now how about this one? Okay, we didn't do that at all. Okay, so let's go and talk about that. Okay. So if I give you, if I say if I give you this, if I give you this, I hope that you know how to do all of these. Now, first of all, you know that this symbol just means the derivative of. So it just means the derivative of that, the derivative of that, and the derivative of that. So I think you know how to do all of these, right? Derivative of this is 2x. The derivative of this is 20x to the third. And so on. You know how to do these, right? And this tells you, and just to remind you, the derivative tells you what? The slope of the function, right? It tells you about the slope of the function. Okay, now, you know that there's a function called e to the x. E to the x, right? It's called the exponential function, right? And we can graph that function. And what does it look like? So if I graph it, I want to plot some points. So I might check 1, I might check 2, I might check 3, I might check 4. I might check -1, I might check -2, -3, and so on. Right? So let's do that. Well, we also might check 0. Okay, so how about 0? So I can say, what is f of 0? What is f of 1? What is f of 2? What is f of -1? What is f of -2? I can ask all these questions. So let's do the first one. What is f of 0? That means I put 0 in for x. So I get e to the 0, but anything to the 0 is 1. So this is also 1. So at 0, it's 1. Right? Like that. Okay, so how about when x is 1? So this one we said is 1. And how about f of 1? So then we get e to the 1, which is e. And e is approximately what? 2.7. Approximately 2.7. Something like that, right? So at 1, it's approximately 2.7. So here's 2. So I think that's right, isn't that right? 2.7? My memory fails me. Anyway, I think it's 2.7. So at 1, it's going to be, here's e somewhere, it's between 2 and 3. There's 2, there's 3. E is between 2 and 3. So at 1, it's going to be e, which is about 2.7. And at 2, it's going to be what? E squared. So if e is between 2 and 3, then 2 squared is going to be between 2 squared and 3 squared. And 2 squared is what? 4, and 3 squared is 9, so it's going to be between 4 and 9 somewhere. Right, so let's say it's around 8 or something like that. So let's put it like here. Something like that. And then when x is 3, it's going to be what? E cubed. Now 2 cubed is what? 8. And 3 cubed is what? 2 cubed is 8, and 3 cubed is 27, so it's going to be between 8 and 27. That's a big range, but anyway, it's going to be up here somewhere. Right? So the shape, okay, so now how about at -1? So at -1, this one, so it's going to be e to the -1, which means what? 1 over e. So that's like between 1/2 and 1/3, because e is between 2 and 3. So that's between 1/2 and 1/3. So that's somewhere between 1/2 and 1/3, so like about here. Right? And how about at -2? So at -2, that's going to be what? E to the -2. And that's what? 1 over e squared. And again, e is between 2 and 3. So this is going to be between 1/2 squared and 1/3 squared. 1/2 squared is 1/4, and 1/3 squared is 1/9. So it's going to be somewhere in there, in between those two, right? So it's going to be pretty small, right? It's going to be less than 1/4. So I better put it like down here. And you can see that when I put in -3, it's going to be even smaller. Right? So we can sketch it as something like that. Something like that, right? Okay? So that's the basic picture of our function e to the x. Okay? Now, okay, so that's the answer to that, right? I mean, that's the picture. All right, now, so going back to here, the derivative of this is what? 2x. The derivative of this is something else, 20x to the third, and so on. Now, this function, you also can draw that. And we know how to draw that, of course. It's just that. And then we take the derivative And the derivative does what? It tells me the slope of this function, right? So for this function, we know the derivative is 2x, and 2x is supposed to tell me about the slope of this. For example, when x equals 3, the height when x equals 3 is 3 squared, because this function is x squared. So if I've just put in 3 into the function, it's equal to, the height is 9, but that's not, the derivative tells me about the slope. So if I want the slope, I look at the derivative. So the slope here is what? 2 times 3, so 6. Okay, so the derivative tells you something about the picture. Right? The picture is a parabola, but the derivative tells you something about it. Right? Okay, now we have a different picture. It's not a parabola. Right? Not a parabola. Okay? We can still wonder about the slope at different places. Like, what's the slope here? What's the slope here? What's the slope there? What's the slope at different places? We can still wonder, what's the slope? And if we could find the derivative, then we would know about the slope. But the derivative of this is not the derivative of the other functions that we've seen, because this is not the same function. Right? So we don't know how to do the derivative of this. We don't have any rules for this. We haven't worked with this function at all. And all the other rules don't work for this. I mean, not all the other rules, but basically our other rules don't work for this. So we need, but we still might wonder if it's possible to figure out what the derivative is. Now, just to remind you, because I'm sure you don't remember, this might be a good time to do this. You just told me that this is equal to what? The derivative of x squared is equal to what? Here's the function I'm talking about. So the derivative of x squared is what? 2x, right? You know how to do that. But you don't. But I doubt you remember where this came from. You know the rule, right? Which is called the power rule, right? Which says that the derivative of x to the n, and you know it, right? It's nx to the n minus 1, you know that. But where did that rule come from? Well, we never proved that rule, but where do all rules come from? All rules come from the original definition of the derivative. So, if we have a function f, the derivative of that function, which we denote as f prime, the definition of that was a long time ago. At least 5 classes ago. At least probably five classes ago. And it had to do with limits. And it had to do with, we talked about the slope, and we took approximations of the slope by doing that. And we said, take this one, then this one, then this one, and it's getting closer and closer to this one. And that was this. So just to make sure that that this still works, let's go back and do this, just to prove that this is actually true. Let's use the original definition of derivative to show that the derivative of x squared is actually 2x. So to show one example of this rule, the x to the n rule. Show one example, show the x squared example of this rule using the actual definition. Let's see if we really get 2x. is this really going to be equal to 2x? Because you said it's 2x for this function. Let's go back and apply this definition and see if we really do get 2x. This is a good time to go back and do something like this because we forgot completely about this, right? But this is where it really came from originally. So let's check, see if we really get 2x. So how do we do this? So the function that we're talking about, that we're checking, is this function, x squared. So that's f of x. Now, this formula here requires us to know f of x, but it also requires us to know f of x plus h. That's another piece that we have to fill in. So we know what f of x is, so how about what f of x plus h is? Well, it's just x plus h squared, right? This one is, if we put in x, we get x squared. If we put in x plus h, we get x plus h squared. So this is x plus h squared. So we're going to do all this, and I hope that I actually get this, because this is what we've been using, this formula that gives us this. We've been using it, but it originally came from here. So if we do it this way, the long way, I hope that we get this, because otherwise something's wrong. Okay, so we need to know this, we need to know this, we need to put the h in, and we need to do the limit. Okay? So now we have this part and this part, so let's start. So we have limit. We won't change this yet, still limit. Let's leave that like it is. And then f of x plus h is what? It's that. So this part is x plus h squared. Okay? And then the next part is minus f of x. But that's what? Minus x squared. Right? And then we have h on the bottom. Okay? I hope I get this when I finish here. Okay? Now if I just do the limit right now, we tried this before a long time ago. If we just do the limit right now, we'd put in 0 here. We'd get x squared plus 0 means x squared. Means x plus 0 squared, which is x squared, minus x squared over 0. That's 0 over 0. That's no good. So just putting in 0 right now, we didn't do that. We tried to push it further algebraically, and maybe. So if we go next step might be to expand this part here, and that will work. So we still don't do the limit yet. And then we expand that, we get what? X squared plus 2xh plus h squared. That's this part, right? Right? That's this part. Minus the x squared. Okay, and then divided by h. Okay, but still, if we drop in 0 into this, it's still going to be messed up. It's still going to be 0 over 0. If we substitute h with 0, we're still going to end up with 0 over 0. But we can do a little simplification here. We can cancel that and that. Right? And then then all the top terms, the numerator terms, have h's in them, which then we can cancel with the bottom h. And then we're not going to have that 0 over 0 problem anymore, because we're not even going to have the denominator anymore. Okay, so now we get limit h goes to 0. So this cancels with this, and one of these cancels with that. So now we get what? 2x plus h. Right? And now we can do the limit. And what do we get? 2x. See? The original definition was this. We forgot about this because we had all those rules, so we didn't have to mess with this anymore, for the most part. As long as we could use one of those rules, we weren't going to use this. Right? But you can always use this, and we just did here, in this case, and it worked. I mean, it gave us an answer.